get started, we have Bob Zogg from the HeatSmart Alliance, which is an organization, well, Bob can talk about it more, but he was really the start of the HeatSmart Alliance and really the whole HeatSmart program. He kept pushing the state to run a program, and then for 2 years beforehand. So he was on the bandwagon way before the rest of us. So he's the best of the best. Thank you for joining us. You can take it away.
Thank you, Belinda. You're too kind here. So yeah, let's get started. We're going to talk about green heating and cooling for your home, which really means heat pumps. Bear with me one second. There we go. And the HeatSmart Alliance, which is actually separate from the Massachusetts Clean Energy Center HeatSmart program that is run in recent years, we really have a mission to promote and advance energy efficient heat pumps throughout the state. And that's what we're about. We consider home heating and cooling and water heating applications. We're an all volunteer organization. We've got 56 participants from 29 Massachusetts communities so far, and we are continuing to grow. Basically, our approach is to educate through events like this and through our website. We also provide one-on-one coaching to people who'd like to consider heat pumps for their homes. We do have more demand for coaching than we have coaches available, but we do our best to accommodate, and I know Lincoln provides some coaching in addition to that. And we collaborate with like-minded organizations. And just to keep ourselves honest, we do not accept donations or referral fees from installers or manufacturers, so we don't have any financial incentive in your decisions. So why should you consider heat pumps? First, let's take a look at how we use energy here in New England. And as this pie chart shows, fully 30% of our energy use in New England is for our homes. And that does not include transportation. When we break that down, over 60% is for heating and cooling our homes, 17% is for water heating, and another 2% for clothes drying. That's 80% of our energy in our homes, and all of those loads can be served with heat pumps. So heat pumps are a big deal. If you'd like to decarbonize your home, there's really 3 basic steps. First and foremost, weatherize. That means to air seal and insulate your home to the fullest extent practical. If you're in Lincoln, you are eligible for a free Mass Save home energy assessment, which is a great place to start. And they can tell you what incentives you're eligible for to weatherize your home. But you really want to minimize the amount of heating and cooling you need to do in the first place. The second step is to electrify. This really means replacing your fossil fuel equipment and appliances with energy efficient electric appliances and equipment. And this is where heat pumps come in. Step 3 is to shift to renewable electricity. Whether you do this with solar panels on your roof or whether you participate in Lincoln's Clean Energy Choice program, or there's just a number of ways you can get 100% green, clean electricity for your home. So what is a heat pump? We all intuitively know that heat naturally flows from warmer places to cooler places. We don't have to do anything to make that happen. But if we want heat to move from a cooler place to a warmer place, we need to use a mechanical device to pump it. And that's what a heat pump is. Although we don't call them heat pumps, we actually have heat pump-like devices in our home already. Our refrigerators, our dehumidifiers, our air conditioners all use the same basic technology as a heat pump. And heat pumps are available for home heating and cooling. This means one piece of equipment that does both heating and cooling, which is great, one-stop shopping. They're available for water heating. They're even available for clothes drying and pool heating. This illustration shows how a heat pump can be more than 100% efficient. In this case, we're taking 1 unit of electricity from the grid. We're using it to pump 2 units of additional energy from the outdoors. which delivers 3 units of energy to heat or home. So in this example, the efficiency of the heat pump would be 300%. Some types of heat pumps will get even higher efficiencies. So what are the benefits of heat pumps? I'd like to highlight first the comfort benefits, because these are hard to appreciate unless you've experienced them. Most of the heating and cooling equipment we're used to operates on an on-off cycle. It's either on or it's off, and that results in temperature swings, as this yellow line shows, and our bodies are really sensitive to that, so it's not that comfortable. Modern heat pumps will operate at variable speed, and they tune right into the amount of heating or cooling our home needs. They maintain a very consistent temperature, and it's just wonderful. You don't even realize you've got air conditioning or heating. Your home just feels comfortable. I'll talk about this more in a minute, but the big benefit for the environment is the greenhouse gas emissions reductions, and they're substantial. There's also some energy cost savings depending on your alternative. The savings are modest compared to fuel oil, but more significant compared to propane or electric baseboard. Based on recent fuel prices, it's still cheaper to heat with natural gas, but we'll talk about that a bit more. That doesn't mean users of natural gas should not consider heat pumps. It just is a consideration. And they're safer. There's no combustion in the home, so there's fewer risks associated with that. So how much is the emissions reductions? This is just an example home. It's not your home, but it's a typical 2,000 square foot home in Massachusetts. And we're comparing various types of heating systems here and the seasonal emissions associated with the use of those heating systems for this example home. And as you can see, the heat pump options here, whether it's ground source or air source, really give you substantial reductions in emissions. And if you procure your electricity from 100% renewable sources, these green bars basically go to zero. You have zero environmental footprint associated with your heating and cooling. So that's a big deal. Now, there are a lot of different types of heat pumps, and I'd just like to introduce you to maybe one way to approach this and try to narrow down what might be right for your home. First, we suggest you look at your distribution system for heating. One type is hydronic, baseboard hot water or steam. Steam's a little bit less common these days. It also includes radiant floors. So you'll have baseboards that look like these or radiators that look like these typically. If you have a forced air system, you typically have a furnace in your basement connected up to ductwork that uses ductwork to supply heat or cooling. If you have air conditioning, the vents throughout your home, and then you have some return vents that bring the air back to the furnace. Now, some of you may have a combination of the two, but these are the two basic types. Now, if you have a hydronic system, we suggest starting by looking at what we call ductless mini split heat pumps. These have an outdoor unit that sits outside your home. They're connected to a single indoor unit that's typically mounted in the room that you want to heat or cool. And they're just connected by a couple of copper lines. They don't take up much space, and you don't need any ductwork. Another variation on this mini split is what we call a multi-split. That's simply the same, similar type of outdoor unit. Maybe it's a bit bigger. That's connected to multiple indoor units. So in this case, instead of a one-to-one connection, you could have 1 to 3, let's say. And regardless of which type of heat pump you have, the mini split or multi-split, you have options for different types of indoor units. Wall mounts tend to be the most common. You can also have ceiling recessed units, you can floor mounted units, and you can even have compact ducted units that allow you to condition 2 adjacent rooms with the same indoor unit. And you can keep your current hydronic system for backup or for emergencies. Although they're less common, I just want to briefly mention air to water heat pumps. These are particularly attractive if you happen to have radiant floor heating and you'd really like to preserve your radiant heating system. There are a few caveats involved, especially for cooling, but I won't go into the details right now. But I do want you to be aware that these are available. So if you have a forced air distribution system, you can use a central ducted heat pump. It has an outdoor unit that typically looks something like this. It looks very much like a typical outdoor unit for an air conditioner, except it might be mounted on a pedestal that helps keep it above the snow line. Indoors, again, typically in the basement, you'll have an air handling unit that, in the case on the right side here, this is a unit that has backup electric resistance elements that come on the really cold days to help supplement the heating. So this is a full electric option. Or some people continue to use fossil fuels, and they have a furnace built into the air handler that assists on the colder days. So you continue to use fossil fuels on the colder days, and depending on at what temperature you switch over to that fossil fuel will determine how much of your heating load you switch over to the heat pump. Now, I'll talk about this a bit more on the subsequent slides, but ground source heat pumps are the ultimate in energy efficiency, especially if you have existing ductwork. They're also called geothermal heat pumps, and as the name implies, these extract heat from the ground or reject heat to the ground, depending on whether you're in winter or summer operation. And the heat pump is typically in your basement. It's all packaged in one neat box that ties into your ductwork. One caveat here is that to use these types of heat pumps, your existing ductwork must be adequately sized and insulated and air sealed. And your installers can tell you when they come to your home, they can look at your ductwork and tell you whether it's adequate to use a heat pump. If it's not, no worries, you're still a candidate for the mini split and multi-split options that we just talked about for hydronic heating. They work perfectly fine. So let's talk a bit more about ground source, and the big differential here is instead of drawing heat from the outdoor air, we're drawing heat from the ground. There's a couple different variations I'll talk through for the sake of completeness, but only one is typical in Massachusetts. First, the open loop system where you have a well, you pump water out of the well, it goes to your heat pump, and then rejects back into the ground to complete the loop. I say complete the loop, but here it's actually open, so the water ends up migrating back, in the water table. These are uncommon for two reasons. One, there can be some issues with minerals in the water, but more importantly, there can be some environmental concerns about dumping the water back down into the ground, into the reservoir. Another option is not too common, but sometimes used in Massachusetts is the closed loop horizontal system, where there's a ground loop that's buried underground, maybe 6, 8, 10 feet below the surface. These take a fair bit of space, which is one drawback. And also we have so much ledge here in Massachusetts that quite often it's difficult to bury these loops without running into that ledge. So that's another drawback. And certainly the most common type is the closed loop vertical system, where you may have a series of boreholes, they're basically wells that are drilled, and you run piping down each of these boreholes so that it requires less physical space on your property, and it's also a lot easier to do if you have a lot of bedrock close to the surface. Dandelion could probably tell us better here, but I'd say 500 to 900 feet is a typical range of total borehole depth, and again, it's probably a series of boreholes, 2 or 3 typically. Now, for most systems, you will need maybe 20 by 50 feet of space on your property to allow the drill rig to get access. Again, that's typical. There may be ways to do it with less space, but you do need a little bit of real estate here, even with the vertical systems. So this is the installation of one of our HeatSmart members in Bolton. And as you can see, there's a drill rig right there set up, drilling his boreholes. And this is the top of one of the boreholes. The other is in this trench over to the left. And these pipes are running through this trench to the home, and that all gets buried and covered up. You'll still need to do a little bit of finishing landscaping when you're done, but you can expect, in most cases, the contractors will leave the surface something like this. So you might have to plant some grass seed when they're done. So what are the advantages of ground source heat pumps versus air source? Well, for one, you get better incentives from mass save, and we'll talk about that in a minute. The biggie here from an environmental perspective is 50 to 70% better efficiency than even the air source heat pumps. So instead of, maybe 250% efficiency, you might be 450% efficiency or even higher. That leads to lower energy costs and lower emissions. And the aesthetics outdoors, it can't get any better. Once this is done, it's buried, there's nothing to see, just your beautiful outdoor landscaping. And another nice thing is that for most installations, not all, but for most installations, the heat pump is all packaged at the factory, which helps ensure better reliability and longevity of the equipment rather than having to assemble some of these components in the field. Air source has certainly some advantages. It's much more common, largely because it's less expensive. It doesn't require much outdoor space. You just need a little space next to your house to mount the outdoor unit. It doesn't disturb the landscape, so there's no mess outside. And currently, this is changing, but currently there are more options for air source heat pumps when you don't have ductwork and you want to go with a ductless system. Let's not forget about our water heating. Heat pump water heaters, also called hybrid water heaters, are available. They provide over 60% savings on energy and carbon emissions compared to conventional electric water heating. They tend to have fast paybacks, especially with the available incentives. Any plumber can install one of these. That doesn't mean any plumber will. You may have to check around and find a plumber who's willing to do it, but they don't require any special skills. And basically, a heat pump water heater is a traditional water tank with a little box on top that contains the heat pump. It's all packaged together, typically all packaged together at the factory. And it typically includes backup electric resistance elements that come on in cases of high water demand. There are a few cases where these are tough to install, but if you have an unfinished basement where your water heater is, there's typically no problem with installing these. So don't forget about water heating. Let's talk a bit about costs. And I'm not going to get into the installed costs because they vary a bit, but let's talk about the annual energy costs here. And this is the same 2,000 square foot home we talked about for emissions. In this case, we're looking at the annual cost to heat the home. We're using current and recent costs for electricity and fossil fuels, and we're assuming in all cases the most efficient equipment available today. Now you can see that things are a little different in this plot compared to the emissions plot, in that natural gas has moved up quite a bit. And as I mentioned earlier, it's cheaper to operate on natural gas versus an air source heat pump, and it only barely edges out a ground source heat pump, again, based on current pricing. But if you use natural gas today, you might still be a candidate for a heat pump. If your heating and your cooling equipment is getting old and needs replacing anyway, you may find that a heat pump is competitively priced, especially with the incentives, with what you'd have to spend to replace what you already have. And you may find that the difference in cost for energy is pretty small. So don't rule it out, even if you have natural gas. And the important caveat here is this is based on history. Energy prices are changing as we speak. We know fossil fuel prices are going way up. That's going to drive electricity prices as well. So these numbers are going to change, and that's just a fact we have to live with. We don't know for sure what those costs will look like in the future. So in terms of financial incentives, the good news is that Mass Save has introduced some really nice incentives for heat pumps in 2022. I won't go through these in great detail, but you can get up to $10,000 to $15,000 in rebates for your home. There's even a rebate for an air to water heat pump. There's an incentive for heat pump water heaters, and this nice heat loan is a great source of interest-free money, so don't overlook that. Federal tax credits, ground source heat pumps, there's a 26% federal tax credit. Assuming you have the tax liability to offset that, it's a great advantage. That's going down, I think, to 22% next year. There is also a modest tax credit for air source heat pumps and heat pump water heaters. And all of these heat pumps are exempt from Massachusetts sales tax. Now, if you're not in Lincoln, or if you're in a community that has a municipal light plant, be sure and check with your local utility on what's available to you. In some cases, you may be able to get access to Mass Save rebates, especially if you're a gas customer already. But in many cases, you might be dependent on the incentives available through your light plant. When you do your financial analysis, it's important to look at cost differences and not just the total cost of a heat pump. Sooner or later, you're going to be replacing your existing equipment. You're going to replace your heating and your cooling equipment. So the relevant cost difference, the difference in cost is the relevant number to use here, not the absolute cost of the heat pumps. Don't forget to factor in the rebates, loans, and tax credits. And you may want to consider pricing carbon. What's it worth to you to improve your carbon footprint? Also, there's evidence that home resale value increases by 4 to 7% with a heat pump. And don't forget the value of the comfort improvements. It's okay to be comfortable in your home. And as I mentioned earlier, we have to accept the uncertainties about future energy costs. So keep that in mind. So what should your action plan be? Our main advice here is please do not wait for your current equipment to fail. That means if your heating or your cooling system is over 15 years old, it's time to be thinking about how you're going to replace that equipment and to have a plan and maybe even replace it early. For a water heater, it's even less. Water heaters maybe last 7 to 10 years. If you wait for your current equipment to fail, you'll be in an urgent replacement situation. Most of the time, you'll be forced to replace your fossil fuel equipment with fossil fuel equipment. You may have to replace your air conditioner with another air conditioner. You're going to lock your home into fossil fuels for another 10 to 20 years. And hopefully you want to avoid that. So that's number one. Number two, if you don't have air conditioning and you'd like to add it to your home, this is a great opportunity for heat pumps because they, again, provide both heating and cooling in the same piece of equipment. And certainly, if you're planning a major renovation, an addition, or a new home, heat pumps are the way to go. And in those cases, you can almost always provide 100% of your heat with a heat pump. But to get started, I know the Lincoln Energy Committee has additional information, but we at HeatSmart Alliance also have a website, heatsmartalliance.org, which we hope has useful information and links to other sources that we think will help you. As I mentioned before, get your free home energy assessment from Mass Save or your local utility and weatherize as much as you can. In some cases, you may find that you'd like to get more than you can get from the Mass Save energy assessment. And I personally think it's a great investment to spend a little bit of money, even if you have to pay for an assessment to get one done. And it may cost you on the order of $500 to do that. It's money well invested. Again, get help from your local heating coach as available. And when you go out and get quotes, we suggest you talk to multiple installers. Each installer will discover something unique about your home and give you some different options that you might want to think about. When you're ready to make a decision, please be sure to look at the big picture, the equipment offered, the reputation of the installer, along with cost. This is not just a commodity investment. This is a long-term purchase, and there's more to it than cost. And that's it. I think the plan is to hold questions for now, but I look forward to answering questions when the time comes. Thank you, everyone.
Thank you, Bob, and apologies to everybody for being late. I was working on a construction site today, and I got to this place where I took the Zoom call, realized I'd left my laptop in my work truck, so I had to go back and get it. So next step is to hear from Dandelion. Bob gave a good overview of what ground source heat pumps are about, and so Brian, I guess you'll take it away for Dandelion and tell us what you do. That's what you do and how it's different from others. Go ahead.
Perfect. Yeah, thank you guys so much for inviting me. I really appreciate the communities and activist groups like you guys are really what's going to help. Right? We need to stop lighting stuff on fire in our basements. That's just a bottom line. Like, we can't do that anymore. Whether it's oil, natural gas, or propane, like, we need to find a better way, just as a society. So I was telling a couple people, early on in the call, right? I went to Boston College. I studied environmental science. That's where my head is at. I'm a total tree hugger on this for sure. And heat pumps are definitely the way of the future. Anything we can electrify, the better, the more we can do on an electric grid, because we can make electricity renewably, right? We can't make oil renewably. There's just no way. The efficiency ratings that Bob was telling you about, like, that's really impressive, right? Air source heat pumps, you get about 300% efficient. Ground source heat pumps, you're closer to 500% efficient. It's just incredible the amount of energy that you're going to get out of your heating and cooling system with a heat pump setup. Dandelion itself. So if you guys haven't heard of Dandelion we're the biggest and the fastest growing geothermal installer in the country. We started in New York about 5 years ago, and we've slowly kind of spread through all of New England. So Connecticut was next. We were there for about a year and a half, still obviously there. And then Massachusetts, we just joined Massachusetts in probably about 6 months ago or so. It coincided really well with the huge increase when they bumped it up to everybody gets 15 grand on their projects, right? That's a huge, cool piece. Makes it a lot easier to get a system installed for sure. And Vermont, New Jersey as well. So we're growing, we're going where the incentives are, because that is the states that are really helping and focused on their citizens and trying to help them find a better way than, opening up that oil bill every couple of months and realizing, like, holy cow, like, that's going to be a big number to pay, right? How many of you guys are on oil right now? All right, a couple hands, right? Propane too, propane oil, it's the same basic thing, right? It's coming from the same barrel as well. It's just different chemical constituents, right, to do it. And again, we're taking that fuel, storing it in our basement in a big 250-gallon tank, and then lighting it on fire and watching all of that smoke just go right up your chimney. Like, that's what we can tackle, guys. And that's what I'm so excited about to tell you about with geothermal heat pumps, Dandelion as well. Again, everyone on this call at least cares about the trees a little bit, I think, and the air that we're breathing. So thank you guys for joining me. I'd love to tell you a little bit more about Dandelion. If anyone has questions, I'm happy to answer them. I see there's some coming in on the chat, and that's great. And I could try to get to those after I'm done talking. But if there's anything up top of mind that you want to jump in, happy to do so on that. So I'll just pause here for now and see if anyone has any top of mind questions for you. All right, I'll jump in a little bit about Dandelion. Again, biggest, fastest growing geothermal company. We're the first company that's ever tried to make geothermal big, right? There's other geothermal companies out there. They're smaller, mom and pop shops kind of thing, right? They have a couple drill rigs. They probably do other things besides geothermal. Dandelion just does geothermal, just does residential. That's all we do. And we're installing So last year we installed 60% of every geothermal system in the state of New York was a Dandelion system. This next year coming up, we're going to probably double that and keep going. So with that, we obviously have a ton of expertise and just experience putting systems in, as well as we can just candidly just bring our prices way down, because right, when we buy a heat pump from the manufacturer, we're buying 500 at a time, not 5 at a time, right? So that just the cost structure can come down. Our design process is so much tighter and more efficient to just really get it in, and we can get some prices that when I've showed prices to a couple people in Massachusetts, and they say, "Holy cow! Like how are you doing that?" And that's really what we're able to do because of, again, our business model of owning the whole process. So take care of the drilling and the installing and the design work and the permitting, everything to get you up and running. Dandelion can handle kind of in-house, and we do that for you, right? So that's why we can give you just, here's the price. That's what it's going to be. There's no surprises. There's no scary, like, well, if we hit a big boulder at 300 feet, we're going to charge you an extra $1,000. Like, none of that, right? Like, we're just going to give you, everybody pays basically the same price, right? Your neighbor is going to pay the same prices as 2 houses down, even if the geology is way different. It's just a really easy, simple process with Dandelion. I hope you guys check it out. Hope you give me an email. I'll put my email in the chat. You can say, and in 5 minutes, I can just, with your address and who your electric company is, I can give you a pretty good estimate of what it's going to be. Because again, there's no hidden fees or anything scary with how we're trying to set it up. And good question. So Belinda just put it, how big are our rigs? One of our kind of distinguishing features is that we're using much smaller rigs, or we have the ability to use much smaller rigs. The picture you saw earlier is a big standard drinking water well drilling rig, right? We've seen those all over. Dandelion's invested in rigs that are almost a third of that size. So they're 6 feet wide and like 10 feet long. Some of them, they're just so much smaller. We imported them in from Europe. We have more on the boat coming over just as we grow and things like that. So we can get into much tighter backyards. Right, our market is the suburbs. We're trying to bring geothermal to the suburbs, and the suburbs have small backyards sometimes. So everything we've done is try to make everything smaller. The impact to your yard, the drill rig size, and then obviously the cost as well, to bring everything to a place where it can fit in a residential setting. So I'll look at a couple questions coming in. So we use Enertech heat pumps. They're out of South Dakota. They've been making heat pumps since 1996. So a great company. They partner up with us really well. They have a standard, for example, they have a standard 5-year warranty on all of their heat pumps. But because they know and trust Dandelion so much, and again, we're buying 500 heat pumps at a time, they double that warranty for all Dandelion customers. So you get a whole extra 5 years, so a full 10-year warranty, just because they know and trust Dandelion's designers and installers as we go through. Yeah. Bob talked a little bit about the ductwork setup. And yes, ductwork is usually really important for a geothermal system, right? It's going to have a bigger air mass flowing compared to what you're used to with like a furnace, a combustion-based furnace. So the ductwork and specifically the diameter of the ductwork is really important. That's something that we'll assess as part of our process. Make sure your ductwork is big enough to handle the amount of air flowing through. And that's with Dandelion, that's every heat pump manufacturer, right? Like the amount of air going through is a really important factor that you take into account. Right? A furnace can just like keep lighting stuff on fire and not really care about efficiencies and things like that. So like they can just keep lighting stuff and go through. A heat pump is much more finely tuned and better designed as the whole process goes through as we go. So has anyone had a consultation with Dandelion yet? I know, so.
I have mine scheduled for tomorrow.
Oh, perfect. There you go. Great.
Yeah.
Do you know who you're meeting with? Maybe it's me.
It's not you, right?
Okay.
It is. Let me tell you who it is. I can tell you who it is.
Yeah. I know. I already met with Scott Rodman. We're working on his design now for his new house that he's building. Well, as you look that up,
Patrick. I'm talking to Patrick Schmidt.
Oh, okay, cool. Yeah, so that and that's a great. So that's sort of how our whole process goes. So So Patrick Smith, he's one of our kind of call him our SDR. He's our kind of like our intake conversation, right? So you have initial conversation with Dandelion, and it lasts 5-10 minutes or so. They talk, they look up your address on Google so we can see what type of yard you have, what type of house you have. Actually, a couple just preliminary questions. And then if they say, great, your house looks like a good fit, then they take you to the next step and you'll meet with someone like me. I'm an energy consultant, and we'll go in and it'll probably be an hour-long conversation over Zoom, just like this. I'll ask you a bunch of questions. We'll look at pictures of the house and kind of together come up with a good idea of what the system will look like. At the end of that call, I'll give you, hey, this is how much it's going to cost. What do you think? And then hopefully you say, awesome, that looks good. Let's move into the design stage. And then we'll talk, we'll go through a data collection process. So additional pieces of data. So you'll take pictures of the outside of your house through an app that we'll send you called Hover. And actually, if I can see if I can share my screen here, I'll show you what that looks like. All right. Oh, I was pulling up. These are the specs for the heat pumps when we were talking about. So remember when Robert was talking about the efficiency ratings? So that would be in here, the COP, coefficient of performance. So air source heat pumps, they usually max out about 3 or so. Ground source heat pumps, right, we're looking at 4 and 5s for efficiency ratings in heating. And then the cooling is also about twice as efficient for a cooling setup. Because if you go back to the idea of where we dump in the heat, an air source heat pump or an air conditioner takes heat out of your house and pushes it outside. Well, it's hotter outside than it is inside your house. That's why you have your air conditioner on. Ground source heat pumps can take that heat and just dump it back down into the nice cool earth. A whole lot easier to push a ball downhill than push a ball uphill, right? Same idea. So that's where the efficiencies both in the wintertime and the summertime just can be so much better with ground source when you're tying that heat pump to a ground loop. Okay, and then I was going to show you Hover, right? So Hover, this is my house here. This is one of our data collections apps. Well, you take pictures of the outside of your house from a couple different angles, and then we use that to create a 3D model of the house. I could take this. All right, so this is my house here. I'm in this window right now. You could, I guess I could wave if it could, but. And then, so with this, we can measure every single window. We can measure every wall. We know everything about your house. So we can exactly calculate the heat load for your house, right? That way we can put in the right sized heat pump. It's like Cinderella, right? You want the exact right size. Too big is no good and too small is no good. So we're going to design it so that we replace and give you a heat pump that will give you 100% of the heat you need and 100% of the cooling you need. There's no supplemental heat. There's no backup natural gas hookup still or anything like that. It totally does the whole entire house with geothermal, with no need for supplemental heat at all. And that's an important factor, right? Massachusetts is going to give you $15,000 for your project. They don't want to do that if it's only going to be a halfway solution, right? All right. So that's a little bit about how Dandelion goes from a couple initial conversations to a design for you, and then we can get the ball rolling on it. One other factor that Bob pointed out, which made me chuckle, was the time to look into heat pumps is not after your furnace dies, and that is 1,000% true. Absolutely. So there's a lot of design work goes into it, a lot of permitting work that goes into it. This is definitely not something you can get the next day. At minimum, you're looking for a couple months to get it installed, and then. Candidly, with our backlog right now of just people just like banging down the door to get it, right? We're looking at almost a 12-month backlog for installations right now. And that's just, again, because the price is great, the efficiency is great, the technology is great, and having 0 for your oil bill is really, really great. All right. And then, so one thing I show, right, one of the questions is always like, how much does this thing cost? And what I can do with Dandelion, which is so great, is I can show you exactly how much it's going to cost. Because again, it's going to cost the same for you as everybody else. So for example, I'll show you kind of the direct pay option. We have a bunch of financing options. Some of those have state programs too, if you want to finance it out. But for example, this is a typical 5-ton unit. They come in different sizes too, but we'll say a 5-ton unit. Starting price starts at $43,000. With all the incentives, you get $43,000 worth of design, equipment, installation, $43,000 worth of stuff. You only have to pay 20 grand for as you go through. This is taking into account the 15,000 that Mass is going to pay. And they actually just pay that right to Dandelion. So that's how we worked it out with the state. You don't have to outlay that 15,000 or anything like that. It goes directly to us, a couple months after you get installed, or, whatever it is. And we'll cover you for that until we get paid for that. It comes completely out of your contract. So your contract with us will be 26. And then once you get it installed, this is the 2023 tax credit number. So 22% of a federal tax credit gets you down to a net cost of about 20. And Bob, you made a good point again. Like, it's not just how much does this cost, it's what's it replacing and what are you avoiding, right? If you're looking at a new furnace and a new air conditioner unit, how much is that, right? $12,000-$15,000 or so, something like that for both those new. So if geothermal is probably a little bit more, a couple $1,000s more. But if you just think about like what you're getting, it really starts to make an amazing opportunity for so many homes. And again, part of the reason why we have a 12-month backlog is because this is such a great idea for so many people, especially in Massachusetts, right? We just started in Massachusetts 6 months ago, and we were just overwhelmed by demand because I think people were just waiting. They saw what was happening in Connecticut, they saw what we were doing in New York, and they just were waiting for us to finally come to Massachusetts. So how are we doing on that? Is this a price that you guys have seen before with ground source heat pumps? Is it, most of the time when Massachusetts people say is like, it's much lower than what they've seen in the past. And obviously that's our goal, right?
Do you have a sense of what the operating cost is once you have it installed? Because it's going to use more electricity, right? Presumably.
Yeah. No, another cool thing we can do with Dandelion is we can tell you exactly how much it's going to cost, right? So I'll go fuel oil. That's usually the easiest conceptually, right? So if we put in how many gallons of oil do you use, and then cost per. Who's the last person to buy fuel on the call? What'd you guys pay?
$6.
$6. All right. So we put in $6 for that. Efficiency of an oil burner is probably closer to 80%.
I think it might be 84.
Right, is my guess, right? 84, perfect.
I think that's what we said last time.
Yeah. So with this calculator, it's such an easy calculation because this every gallon of oil has a certain amount of energy in it, right? And you're lighting that on fire to get that energy. So we can calculate, all right, if you burn 1,000 gallons of oil in your basement, which again, just like take a step back, that's a crazy big number every single year to just light on fire. And now we take that energy. This is how much heat your house got with 1,000 gallons of oil. How many kilowatts will it use to move that same amount of heat into your house, right? Price of kilowatts, I think it's like 24 cents or so in Massachusetts. Does that sound right, guys?
I think it's
25.
28.
5, yeah.
Okay.
5, yeah, in
So
that
20
range.
25?
Yeah.
All right, perfect. Sometimes I show people this and I just realize like, wow, my job is not very complicated, is it? Like, I'm just putting in numbers and showing you guys what it is, right? This is what your operating costs would be for using those same numbers, right? 1,000 gallons of oil, $6 a gallon, and then 25 cents per kilowatt, what that would be. So instead of paying almost $5,500 in the wintertime, you're going to pay $2,000 in the wintertime of electricity. Instead of in the summertime paying $675, you're paying $318, right? So you're saving thousands of dollars in the winter and hundreds of dollars in the summertime. You add that all up, and if you continue with buying oil, Tarif, right? You're going to spend an extra almost $4,000 a year.
Right.
And that's why if you have, if it costs you an extra $10,000 to get geothermal compared to a new furnace and new AC, that's a really quick turnaround, right?
Right. Less than 3-year payback.
Yeah. And if you wanted to finance it, so you have the Mass Save loan, which is the 0% financing for 7 years, which is great, right? Max of 25,000. There's a rumor that that's going to get bumped up to 50 grand as a max. Anyone else hearing that rumor? Yeah. which would be a great rumor. I would love that. But if you want to spread it, like let's have the smallest monthly payments possible. We have also, partners. This is our partner Enerbank. They're a bank that focuses on renewable energy projects, solar panels, geothermal, things like that. And assuming that you take your federal tax credit and put it towards the loan, you'd be at $160 a month to put that in. It's a 20-year loan, 4.99 interest rate. This is zero money down too, right? So nothing comes out of your pocket. And this loan actually even has an 18-month period where there's no required payments. So you get installed next spring, 18 months after that is when you'd actually have your first payment.
Can I context switch and go back to Bob's point about weatherizing? You guys mentioned a whole bunch of alternatives, but no companies or people that we should talk to about, like, other than getting mass save, which I think they can only work within the walls, but they don't do anything outside the walls to try and replace the windows or whatever. Are there firms that we should be looking at?
Yeah. So it's nothing that Dandelion does. Like we're super focused on geothermal, but we would definitely recommend anything you do to tighten up that house is a really great first step. Right. Because I'm
just wondering if there are firms. I mean, Bob, you mentioned a whole bunch of people. Is there somebody that we should be talking to, or is that on the HeatSmart Alliance website?
Are you asking for names of individual
Yeah,
firms?
or firms. Yeah. I mean, are there people that you guys would recommend that we talk to? Because it feels like that's also a useful thing to do. It's like not just have a more efficient way of earning energy, but actually don't need removing the need. And that was your number one item. So
That's usually the quickest way to save money is good weatherization. Best money you can spend. So, and from my perspective, what you're describing is a real need. It's finding reliable firms that we can recommend, that we can say, this company can do a great job with this. And I don't have a list of those yet. Okay. I don't know, Belinda.
Yeah.
But anyway, we're working towards it.
I thought I'd ask the obvious question. Sorry, it's fine. If the answer is we don't know yet, because that's good. Thank you.
It's a huge gap right now, honestly. We've been through it with Mass Save, and Mass Save has very defined parameters of what they will talk to or not to talk to about your house. And it does not include things like windows and doors and a variety of other things. And it's a huge need in this sort of environmental industry for people to be able to come in and give you a whole home assessment, just not related to the various parts of insulation and weather sealing. It's a huge gap right now, and it's pretty frustrating to deal with, honestly.
Yeah, and again, the better your house is, the less, maybe the smaller heat pump that you need, right? Because we're calculating the heat pump based on your existing house. If you then decide to spray foam everything and get all new windows, you're probably going to need a smaller heat pump. And then that's, if it costs you $4,000 of insulation, but your heat pump is now $4,000 cheaper because it's a smaller heat pump. Awesome, right? That's great. And it's going to run less, which is also a nice factor too.
Right.
The problem is, like, I can't I don't have a single recommendation from anyone. I'm like, okay, people in and
or like who to call. Yeah.
Who do you call? Like, I'm happy. I call Dandelion, right? So we take a look at it sounds like I'm a year away, right? Is there anything I can do today to move the needle forward, right? And that's what I'm asking.
Yeah, and that's what insulation can happen tomorrow for sure. Yeah.
Brian, question on ground source heat pumps. What's sort of the BTU capacity of a larger size unit, and how do you handle it if you have a home that exceeds that? Do you install two? Are you doubling the cost, or is there efficiency using a single loop, or do you need to drill 2 loops?
Yeah, a really great question. So when we calculate the heat load for your house, if it exceeds our biggest heat pump, which is a 6-ton heat pump, then you would need a second heat pump to make that work. Very often it's as many, like, how many air conditioner units do you have outside? Because then you're going to have separate duct systems. So if you have 2 air conditioning units outside, that means you have 2 separate duct systems. So you'll need 2 heat pumps for each duct system. So that's usually how it is. It's usually a 1-to-1 ratio. It's not often that you take a house that only has 1 furnace and 1 AC and needs 2 heat pumps, for example. When that happens, It's a bummer, right? Because that makes it a lot more expensive. Yeah, there is some cost savings, but not a tremendous amount to go from one heat pump to two heat pumps. You need to drill more. You have a whole nother heat pump. There's more design that goes into it, more installation time, a lot of more, more labor. So it's about double, but not quite double to have a second heat pump. In fact, I can even just show you what it is. Hold on.
Just so my own edification though. So are you running 2 loops or do you build a bigger loop? And I'm just curious.
Bigger loop. Usually.
Gotcha.
So each ground loop can handle up to 12 tons of heat. So if you have
Okay.
more than, right. So this is showing one heat pump as a 5-ton down in the basement and one heat pump, a split unit. So this would be up in the attic space to replace the air handler up there, maybe a 4-ton, right? So here's you went from 20,000 to 46,000 on it. The mass save incentive just stays at 15. And that's how Massachusetts did it. Other states do it differently, and they just give you a per ton incentive. So it continues to rise as your heat pumps increase. Massachusetts just, everybody gets 15.
Cool.
Yeah. How many ACs units do you have at your house?
2.
Okay, yeah. So you probably need to you would need 2 heat pumps, and you're closer to this price.
Yeah, we call it 250,000 BTU load.
Okay. Yeah, I mean that's a pretty big one. Although I will just take one step back. Just because your furnace is rated for 250,000 BTUs doesn't mean your house actually needs it. Right? When the person that put in that furnace decided what furnace to pick, he was like, I don't know, I'm just gonna pick the biggest one because why not? Right? They can still continue to do that. There's no regulation over what size furnace to install. There's a whole lot of regulations on what size heat pump to install because of all these incentives. It's like the wild, wild west with furnaces and air conditioning units too. They can put in whatever you want, and bigger isn't always better. Right? If your air conditioner is too big, you're going to have weird airflow issues. You're not going to pull out as much moisture in the summertime as you should, and therefore you're going to have a much clammier, like uncomfortable environment. So you really do want to focus on the right size, not just the biggest. Right? In America, bigger is always better, but not when it comes to heating and cooling.
Don't worry, we have 2 smaller ones, not one big one.
There you go. Yeah, awesome. How are we feeling on? Like I got a couple slides. I don't know how much time I have left, or how you guys are doing. Maybe Michael or Belinda. I could talk forever, so I don't want
to bring it to a close shortly. I mean, you can, if you got a couple more critical things, cover those, and then move on.
Yeah, I'll go down and show you. You guys sound like you know how it works, so I'll skip that one. Here's what the heat pumps look like. This is my favorite slide, right? It's just incredible, the environmental impact that you're going to have on your house. Just eliminating, again, thousands of gallons of fossil fuels for you. The other thing I want to show you is our drill rig. So we have a couple different types of drill rigs, right? Here's the one you saw before. It's just a standard water well drilling rig, and these are our smaller guys, especially the Camacho over here. Which again, like you see the person right there, that's a tiny drill rig. So that's where it can get into a lot of different, smaller avenues. And it's a much quicker drill. Like it's awesome. It's perfect and designed for geothermal. So I guess in closing, Dandelion, we would love to help you. I personally would love to help you. Again, I'll add my email to the chat so you guys can give me a buzz. Or if you call Dandelion, please just ask for me and I'll be able to hook you up with what we need. And we'll talk, right? It takes 5 minutes to come up with a good cost estimate for you. And then we'll go through the whole process to find a way to make it work. It's definitely something we should at least look at for everybody's home in Massachusetts, because it can be such an awesome benefit for everybody.
Thank you, Brian. Yeah, we put in air source heat pumps 7-8 years ago, and mini splits, and I was just, and still am totally sold on them. And I always had ground source heat pumps in the back of my head as a great idea, but not affordable. So just forget it. But then just recently, I started learning about some changes, and especially Dandelion. And I said, oh my gosh, you start looking at the numbers, and especially as long as you're in this year or next year before hopefully the federal tax credits get extended. But if anyway, that
I think they will. Yeah.
I think they will too. But some-
the Build Back Better program had it at 30% for 10 years.
Gosh.
And
that's awesome.
everybody was happy with that. Like, it just didn't pass because of all the other, nonsense and that, whatever it was. But that was agreed on. And I think that might even happen this year, that it bumps residential and commercial up to 30% and extends it out for 10 years is my
That
hope.
would be the way to go. So
Yeah.
anyway, so it's just, this is a really, really hopeful developments. So
Excellent.
excellent work. So
Great. And I see there's a bunch of questions on the chat. I'll just jump into those now as they get answered. Okay. And thank you guys again. I really appreciate this. If anyone has any questions, I love talking about this stuff. So please give me a call. As Scott knows, that who I've already had a consultation with, I'll talk about this all day long.
Brian, did you share your contact info somewhere?
I'm doing it right now. I'm typing away. Yeah.
okay, so let's switch to a couple of Lincoln neighbors who put in different systems, and we'll start with Tom Longnecker, who put in a geothermal system. And let me share my screen. And hold on a second. You got to find that guy. Hold on a second. Belinda, do you have the neighbor slides easily handy? Every once in a while, when I do share, things hide on me. So go here. Neighbor slides, okay.
Can you see them?
Okay. Now I go back here. Sorry. All right, so.
We're seeing Belinda's slides here, so.
Oh, you are? What the neighbors installed? You seeing that?
Yep.
Okay, perfect. Okay. So, all right, so step us through these, Belinda. So, okay. So this is Tom Longnecker. So Tom, you're on, right?
I am here.
Okay,
Glad
so
to talk about it.
yeah, go ahead.
I learned about the HeatSmart options in 2018, and we were, I'm sorry to say, able to get in and out of the whole project within a year. Sounds like that may not be Dandelion's timeline now, but we were pleased with how quickly it all worked for us. We went from having forced hot air oil system. We really wanted to get rid of our oil and put in two ground loops for the geothermal ground source heat pump system. Inside, clearly outside there was a lot of disruption as they drilled the wells. We had the big rigs that we could fit in there. Didn't realize how much landscaping would be available to us afterwards, and benefited from that by putting in some new stonework. In the background there, I will point out, I've got a wood pile. We are very, very happy with our geothermal system. Our home is way more comfortable than it was before, no more cold spots, but there was also no direct heat source, and we designed our home originally with the wood stove in mind. So we like having both geothermal and a real source where you can stand by and warm yourself. So otherwise, the house is just always the same, very comfortable temperature. And if you
You break. Is Tom breaking up?
that I had to what I heard presented, because I heard great on Bob. Thank you.
Tom breaking up?
Oh, I'm sorry. Well, tell me to repeat if I need to.
Yeah, you just lost a sentence or so.
Okay.
So, you good.
The number data that I heard from Brian all seemed to match up with our experience. Everything's in line. The details that I didn't hear is just the benefits of not burning oil. I feel great about that. I no longer have an oil tank in my basement. I love having that extra space. Because we had a forced hot air system, they basically put the new water furnace heat pump in the same footprint as the original furnace. So there was no change to the basement there. The part of the installation did include analyzing our ductwork, and they had to add some more ducts to allow for the increased circulation. And that ended up also eliminating some of the cold spots within our home. So we really are more comfortable because of the system.
Cool.
I'm open to any questions if there's anything else that I missed there, but we're fans. We're glad with our investment and have been comfortable since.
Excellent, excellent, excellent. Okay, let's go on to Justin. Let's
Hi.
Here, Justin.
So I'll give you a little backstory. Just we moved into our house in 2020. It's a complex house. It was 3 buildings in the 1800s that have been merged together. But when we came in, one of the air conditioners was 25 years old. The other one was probably 18 years old. So they're pretty high on the list, and they weren't keeping up with the load in the summer, and so we knew, the pressure on them was dropping a little bit below where it needed to be. And, you're not really supposed to refill with R22 in most cases. So we embarked on this journey to replace the air conditioners. And I'll be honest, when I started out talking to people, I was like, I just want to replace the air conditioners. I don't want to get into the heat pump conversation. And we did have one installer who came in, and I'll give him credit like I do with anybody who comes in and says, hey, look, I understand your point of view, but give me 30 minutes to explain why this would be a good decision. And he did, and he was compelling. And so we ended up replacing them with heat pumps. Right. So we actually had them relocated to the side of our house as well, which was really nice. And replaced both of them, moved them there. And I think one of the big benefits is they do both heating and cooling, which is nice. Right. So instead of you're kind of spreading that cost against heating and cooling your home, as opposed to just heating or just cooling. Ours go down to about 25 before we need to use auxiliary heat. And as somebody mentioned earlier in this presentation, you really need good installers, because of a lot, it comes down to your ductwork sizing, the balance points, coefficients of performance, and figuring it all that out. In one area we have smaller ductworks, so we can't quite push the load through that probably should be there without, but the ductwork's expensive. But overall, we're happy. Our air conditioning costs are certainly down, I'd say, 25%. We've done some insulation work as well, so these numbers are influenced a little bit by that as well. And cooling, heating, definitely happy with the performance there. We do use auxiliary backup oil, but that will change when those. You can see the condenser unit sitting on top of the furnaces in the right-hand picture, and that will change when those come to the end of their lifespan. But just from a financial perspective, it feels smart to use those till their end of lifespan and then explore other options. Maybe ground source heat pumps is one of them. But I'm happy to answer any questions for anybody at any time about our experiences. We were very happy with the people we used. I don't know the policy on giving names out on this, so I won't. But if people want to reach out to me individually, I'm happy to provide that.
Excellent. Super. Thank you, Justin. And
Yep.
find it nice to see you and your face
pleasure.
after lots of back and forth emails. We had some interesting discussions about the cutoff point between the heat pump and your backup. And so I learned some good things from Justin. Okay, so on to Kathy. Is Kathy with us, Belinda?
No, she isn't.
Okay. So you probably spoke with her about this. Why don't you just talk briefly about what she did?
So Kathy has a very long house, and so she replaced 3 different gas furnaces and with 3 heat pumps. And there's now 5 zones instead of just having 3 zones, which is great. You can see 2 of the large compressors here, and then she had another small one. And she had this done in February. So she doesn't have much data, but she said that the system was very quiet, which pleased her. She said it's much quieter than her previous gas furnaces.
Great, very great. Okay, so let's open it up for Q&A now, and we'll go to the chat and see, I don't know how far back we've got. Anything, do you see, Brian, that haven't been answered yet?
I think I might have just answered my last question. And sorry, I was going through them all. So hopefully.
Okay, okay. So you've been answering directly on the.
I've been
chat.
trying to go, and I tried to go in order as best I could. If I missed anybody, please, jump ahead, and I'll answer it right now.
Okay, gotcha. Okay, so any other questions for Tom or anybody else, and for Justin, and or in general about the whole, for Bob? We covered a lot of material. Anybody who's thinking about this and saying, "Oh my gosh, what do I do next?"
I'm psyched about this for what it's worth. I mean, I had reached out to Dandelion and I could not get we finally got the call scheduled, but I'm really excited about the possibility. Not so much about waiting a year, but
Yeah.
I know, yeah, it is the negative. So
timing is excellent.
we fully recognize that like a year is longer than people want to wait. We get that, and we're working on that. But really, we just need to hire more people, and we're trying to hire 40 more installers in the next 2 months, right? Like it's hard to find them, right? So if any of you guys are installers or excavators or drillers, like we will hire you today. Absolutely, it's a labor shortage. It's really a problem.
I concur with Sharif's comments. I'm excited about it too, and we hope to be going with Dandelion.
Awesome, that's great, guys. And again, just as a quick personal plug, please let me help you guys. I would love to be able to do that. I can, do my best for you if you come in and just mention my name or just shoot me an email directly.
Dilla has a question. I have to unmute now, Dilla. You have to unmute. There you go.
Fred. There's a fair chance our house is a tear down, and it should probably tell we won't be in it for much longer. And if it's a tear down and a new house is built, can the geothermal unit be moved or retained?
Yeah, a great question. The ground loop that we installed is really specifically designed for your house, right? The exact right depth for your house. Everything is really designed exactly for your house. So if you then tore down that house and built a new one, unless by chance it needed the exact same heat load for your house, it wouldn't really be able to be reused. And no, the pipe can't be pulled out, right? It's 500 feet in the ground and encased in bentonite clay and things like that. So yeah.
All right. Thank you.
Anyway, this is really exciting stuff, and just great opportunities on lots and lots of fronts. And as I said, we put ours in 7-8 years ago, and solar as well. I didn't pay an electric bill for 4 years, and we got an electric car, and suddenly that was more than we could generate on the roof. But I see Tom has had collectors on his roof too. So I mean, if you can get those all in place, the future is just relax, and the sun does all or virtually all, and everything else you can get from renewable sources easily. So this is what the Green Energy Committee is pushing for, is to get as many people as fast as possible. I love what you said, Brian, setting things on fire in your basement. I mean, it is so like 16th century. It's just insane. Yeah. So anyway, we're moving, and we need to keep moving quickly. And glad to see Dandelion's working to expand, and we'll see what should our neighbors do. Maybe on our next one of these calls, we'll have some more people to add. So okay, if there are no other questions, we'll wrap it up. And thank you so much, Bob, for making time and sharing what you did. And Brian, you too. Really, really good stuff. And thanks to everybody for attending. And you all be well.